Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this session, we will talk about the structure in general. Then after that, we will talk about the structure of the building. Although few people give structure or structural design any thought, they are surrounded by natural and designed structures. They live in them, travel in them, eat with them, sleep on them. They contribute to almost every aspect of their lives. In prehistorical times, humans routinely used structures. Indeed, humans, animals, and plants are themselves structures. Many animals build structures. For example, bird, they make bird nests, and spiders, they make webs. Most group of prehistorical people regularly use structures in their daily lives. They built forms of housing and constructed boats, bridges, weapons, and utensils. Each group tended to produce different designs for the artifact. How this design process worked is not known, but eventually traditional designs evolved. These traditional designs became fixed and part of the total culture of the group. When group of people become civilization, it is an evolving rather than a static culture. New types of buildings were required, and then temples, storehouses, castles, and so on. As the traditional methods no longer applied, new technology and design processes were required. This did not always lead to success. And then the central requirement for all design processes is to have a method of evaluating the outcome of the process design. In the traditional system, there are no new problems, and the performance of an artifact is known from experience. It is clear that early civilized builders thought deeply about their new buildings and often appeared to have clear ideas how their structures behave. However, the acquisition of the technical understanding of structural behavior was slow and took a long time. It was only during the 19th century that the majority of this knowledge was discovered. This, of course, did not prevent builders constructing the most amazing structures, from pyramids to cathedrals and from catapults to water wheels. The successful design of any structures requires satisfactory answers to the following question. The first, is the structure strong enough? And then, is the structure stiff enough? And although this may be stating the obvious, the answer may not be readily obtainable. Furthermore, before attempting to answer these questions, two further questions must be answered. These are: what is the structure, and what are the loads? The most common answer to the question what is an structure, what is an engineering structure, would be along the line something that carries loads. Uh, Well, there is truth in this. It needs to be extended to the concept of carrying loads from one place to another, that is transferring loads. A simple example illustrates this. If people want to cross a stream, yeah, then a plank could be used as a bridge. Where people are on the bridge, their weight or the loads are transferred from a point over the water, which cannot directly support them, to point on the banks which can. The purpose of the plank is to transfer the point load to the point load of support. The plank does this by acting as a structure. The diagram can be redrawn showing the applied loads. Yeah, the people. Here applied loads is the people. And then the structure, the plank. And then the points of load supports are the banks of the stream. It is more usual to call the load supports direction. This load transferring function is the main purpose of all structures, whether it is a chair or the railway bridge. The role of structural design is to choose structures which will transfer the load satisfactorily. However, this is far easier said than done, because there is a wide choice of structural forms and a range of structural materials which can be used. Furthermore, demonstrating that the chosen structures will perform satisfactorily can often be a major task. Okay, this is an example of a description of the existing structures in a building. When it comes to structures, think of the bones in our bodies. If there are no bones, our bodies cannot stand. Yeah. Same with the building. The building needs, like, we can say, bones. They have column and they have plate, and then column capital, slab on grade, pedestal as foot, and then we can call it spread footing, basement wall if they have basement, and then uh, there is stairs, column, foundation wall, beam, beam, and then wall footing. If they have wall, they have to has a wall footing. Here is the example of steel building. Yeah, they have a rafter, and then column, wall bracing, pier foundation, portal arch, roof system. Yeah, here. This is the other example. There is purlin, and then if purlin, end wall kirts, side wall kirts, yeah, etc. Yeah. Uh, Many elements of the building structures. The building depends on what we talk. Each building will have different structural element, but in general, sure, there are columns, beams, uh, floor slab, and foundation.